characteristics 2 and 3, which was step 3 in ours. When do we have horizontal asymptotes? When do we have oblique asymptotes? Okay? I'll summarize this in the end, looking at this first equation. It's all based on where the degree is. In this situation, the degree is larger in your denominator. Whenever the degree is larger in your denominator, you will always have a horizontal asymptote, and that horizontal asymptote will always be at 0. I should say in the denominator, but I wrote on bottom already. Not as good math language. Whew, that sounded like a terrible English sentence. Not as good math language. Anyways. So if the degree is larger on the bottom, you will always have a horizontal asymptote, and it will always be at y equals 0. Okay? And I'm going to just add at the top that one of the things, because step 1 is looking at non-permissible values, holes, and vertical asymptotes, if something simplifies so that you end up having a hole, you then always graph what you have after you've simplified. So sometimes situations disappear because your equation becomes simplified and you don't have to worry about it. Okay, so here is equation number 1. Sure enough, there is an asymptote at y equals 0. Can you see that this one has a non-permissible value at -4? It doesn't cancel out. So you have a vertical asymptote at x equals -4. Then you would have found some nice points and then just drawn your graph after that. Example 2. Okay? And again, I'm going to say that the textbook here overworks this a little bit. We can do this a lot simpler. So in this case, I'm going to just write the degree is the same. Whenever the degree is the same, you will always have a horizontal asymptote at y equals the coefficient divided by the coefficient of whatever your highest degree is. So in this situation, the highest degree is x. They're the same. We look at the coefficient on the top, which is 2, the coefficient on the bottom, which is 1. You will have a horizontal asymptote at y equals 2. Do not worry about what they're showing here with synthetic division or any of this explanation. Just do it the simple way of looking at the coefficients. And finally is the situation where the degree is larger in the numerator. And again, I'm going to write this in red. This is only after you've simplified. Sometimes you start with the degree higher in the numerator, and then after you've simplified, it's no longer the case that you have to worry about it. But in this situation, it is x squared over x plus 1. What happens? You will always get an oblique asymptote, and you have to use synthetic division to find it. So what do? You actually divide. How would I divide x squared by x plus 1 using synthetic division? Well, I would put 1x squared, 0x is 0 constants. Remember your zeros. If you're dividing by x plus 1, you put a minus 1 out in front. Bring down your 1. 1 times minus 1, add. Minus 1 times minus 1, 1, add. Your division statement would tell you that you would get, if I do polynomial as dq plus r, that your q is going to be x minus 1. And whatever your quotient is will be your equation of your oblique asymptote. It doesn't matter how big or how small the remainder is. Whatever your quotient is will be the equation of your oblique asymptote. Okay, so we are going to go to this example. We've got our steps here for nice points. We should remember our x-intercepts and y-intercepts. And so we start. Okay? Step 1, we always factor. Okay? In this case, the top factors to x plus 7, x minus 1, all divided by x plus 2. Nothing simplifies. So that tells us that our non-permissible value, and I know that the question is just worried about step 3 here, but we're going to graph it completely just to run through everything every single time. And if you think of all the steps every single time, it's going to help you more in the end. So our non-permissible value, in this case, x can't equal negative 2. Does it cancel out? No. Since it doesn't cancel out, you know that you have a vertical asymptote at x equals 2. You like numbering things as you go along? That was step 1. That's step 2. Now we're on step 3. What situation do we have? We have the degree larger in our numerator. When the degree is larger in your numerator, you are going to get an oblique asymptote. So for step 3, write out that you know that you've got an oblique asymptote. To find your oblique asymptote, use synthetic division. 1, 6, negative 7. You're dividing by x plus 2, so a negative 2 comes out. Bring down the 1, multiply, add, multiply, add. There's your oblique asymptote. Y equals x plus 4. Ignore the remainder. Number 4, we need nice points and graphs. So what do we have so far? We could draw our horizontal asymptote at x equals 2. We could draw our oblique asymptote at y equals x plus 4. Next, find your y-intercept. How do you find a y-intercept? You plug in 0 for x. Look at the original equation. Can you see that all the x's go away? You would get negative 7 over 2. Yes? Yes, -2. Thank you. Right? X can't equal -2, and then I just forgot to write the negative. This would have caused me problems later on. Thanks for noticing. Now, does your paper let you just slide things over like this? No? I apologize. It's not letting me slide them over very nicely either. There we go. X equals -2. Thank you. Next, we'll find our nice points, which includes our x-intercepts and y-intercepts. Plugging in 0 for x gives you -3.5. There's our y-intercept. X-intercepts. For your x-intercepts, remember, if you put in 0 for y and it's equal to a fraction, the only place a fraction is equal to 0 is if your numerator is equal to 0. Your numerator is already factored. Can you see that your numerator is equal to 0 at 1? And at -7. Now, when we go to graph now, we just need our graph to go towards our asymptotes. I'll do the right-hand section first because it's easiest, because we've got 2 points here. Can you make sense that this one would go to that asymptote there? This one goes to that asymptote there. And we have another point at -7, 0. So this one has to go towards, well, it should probably even be straighter like this. Okay, that's not very straight. That's kind of ugly looking. It should be a nice smooth curve, so maybe it would actually have been more like that. There we go. That one's bad. That looks a little better. Your domain is always separated by vertical asymptotes. We didn't have to find any additional nice points for this graph because we had points in both sections that were separated by the vertical asymptote. We had points to the right of the vertical asymptote. We had -7, 0, which was to the left of the vertical asymptote. Once you draw your graph towards the asymptotes, you're going to be done. There's nothing in this section here, nothing in this section up there. Question number 2. It's the same numbers, so the factoring is easy. X plus 2 and and then over x plus 7, x minus 1. Factoring's the same. Non-permissible values, though, x can't equal -7, x can't equal 1. Neither of them cancel out, so we know we have vertical asymptotes at x equals -7 and x equals 1. Step 1 was factoring. Step 2 was holes or vertical asymptotes. Step 3. Okay? In this case, we have a higher degree in our denominator. Anytime you have a higher degree in your denominator, you will always have a horizontal asymptote at y equals 0. And now we're ready for step 4, which is graphing and nice points. So start off your graph by adding in your asymptotes. We have a vertical asymptote at x equals 1. and one at -7, and a horizontal asymptote at y equals 0. For our nice points, we need to find x-intercepts, y-intercepts, and sometimes some other points just to fill it in. This is a good example of something interesting is going to happen. So in this case, first of all, the y-intercept is really easy because you plug in every 0 for x. Can you see you're left with 2 over -7? So we're going to have a point here at 0, -2 over 7. For x-intercepts, you plug in 0 for y. If I plug in 0 for y, I'll do it up here. 0 equals x plus 2 over x plus 7, x minus 1. The only place a fraction is equal to 0 is if your numerator is equal to 0. When is my numerator equal to 0? At -2. At first, this feels really wrong, right? Because you put a point on an asymptote. It would be wrong if you put a point on a vertical asymptote. Vertical asymptotes are 4 non-permissible values. You can never have a point on a vertical asymptote. But horizontal asymptotes are just there to tell you what happens to the graph with big x values and big y values. So in this case, it's okay to have a point in the middle. So in this situation, we only know one thing. Okay? So far for graphing, these would connect and this has to go down, because if it went back up, you would have another x-intercept, and we found out there's only one x-intercept at x equals -2. So you can't introduce new x-intercepts because we found out there's only one of them. So as far as nice points go, we actually have to find quite a few extra nice points. For one, after -2, in this middle section, the question is, does it go up towards the asymptote or does it go back down? Does it sort of bounce off the x-axis or does it go through? The way that you could figure that out is you could put in another point. Like plug in -3. What would happen if I plugged in -3? What would I get for y? Well, I would get -3 plus 2 minus 1 in my numerator. -3 plus 7 would be 4 there. -3 minus 1 would be -4 there. Can you see that you would get 1/16 positive? If I plug that in right here, -3, 1/16, I now know that my graph has to go up towards the asymptote. Because if it went down, I would introduce another x-intercept. And I only know that there's one x-intercept at x equals -2. We still have to have more nice points, because we have nothing in this section when x is bigger than 1. So next, I'd probably plug in x equals 2. I'm going to take out my eraser, erase this number, erase this number, erase this number. What happens when I plug in 2? Can you see that you would get 4 on the top? 2 plus 7 is 9. 2 minus 1 is 1. You would get 4 9ths. So on my graph, I would go to 2, 4 9ths, and graph 2, 4 9ths. Now that I have a point in that section, it has to go towards the asymptotes. No new x-intercepts can happen. That section is done. I still have one more section I need to do. I have nothing to the left of x equals -7. And so I'd probably choose x equals -8. Plug in minus 8 into my numerator. I get minus 6. Plug in minus 8 here, minus 1, minus 9. This will simplify to be a negative 6 over 9, which reduces to 2/3. So I know I have the point negative 8, negative 2/3. So that section is done. So your vertical asymptotes separate your graph into sections. You have to have a nice point, somewhat nice. I don't know if I would consider 2,4 a super nice point. But you need to have a point in each of those sections in order to figure out where you're going to draw the graph. Okay, so now I'm going to get you that you've seen all the characteristics. You can work on questions 5, 6, and 7, and I would like you to graph them as you go.